and I'm rated as a candidate master in code forces. Also, I have been into ACM ICPC Amritapuri regional, where I secured a rank of around 250. Also, I have been into CodeBeyond season 8 finals, where I got a all India rank of 3 and a global rank of 8. So what I'll be teaching here in Unacademy. So in Unacademy, I'll be taking subjects of C++, data structures and algorithms, competitive programming, and also we'll be discussing some practice questions that will help you crack any interviews that you are applying, right? So in C++, we'll be doing deep dive on C++ STLs, on various concepts revolving around C++. In data structures and algorithms, we'll be working on different data structures, their uses, and in algorithms we'll look into various algorithms, their use cases, their best case time complexity, their best case space complexity, and so on. In competitive programming, we'll be learning some tips and tricks so that we can gain our speed and accuracy, and also we'll be learning how to get good rating on code forces and CodeChef like platforms. So before moving ahead, make sure you use my code SSRoy10 to get 10% off on any courses you apply on Unacademy Plus platform, right? So make sure you use my code. So let's quickly move to the next part. So before starting our teaching, let's look at this amazing thing brought up by Unacademy. So basically we'll be talking about Relevel. So it may happen that sometimes you are applying to various companies, but you are not able to get any job, or you are not able to secure any job, right? So what happens is that your resume does not stand out, your networking in LinkedIn is not good, and so on. So Unacademy has come up with this great concept of Relevel, where they will be not requiring any better degree, or it will not look if you have a poor networking over LinkedIn or other platforms, right? It will also not look that if your resume is not standing out in among hundreds of people who are applying to the same startup. And also if you have applied to 50 to 60 companies, but you have not heard from any other from any one of them, like you have continuously applied but you did not get a interview call from any one of the companies. So Unacademy has come with this concept of Relevel to bridge this gap. So about Relevel, it is India's first tech hiring platform which will help job seekers find their dreams. So basically it will look for your skills and talents rather than your degree or your networking over LinkedIn or other places. So what are the benefits? Your benefit is that there are more than 50 plus companies affiliated to it. There are 100 plus job positions for business development, for front-end development, and for back-end development. Also, you can attempt this test for free. Relevel will not take any cost to apply for this test. And also you will be in a unique position where you have to just apply and you will not have to do any kind of job hunting. So all the companies are brought to you in one place. So registering on Relevel is very easy. What you have to do is that you have to first select a test of your choice. It can be a business development test, it can be a front-end development test, it can be back-end development test. After that, you book a slot. You book a slot according to your convenient time. So Relevel gives you the flexibility to choose the time and date of your own. After that, you create a neat video resume, and that's it. You submit click on the submit button, and it's done. Your registration is done. So make sure you register today to Relevel. A note is there that if you are 18 plus and you have less than 3 plus years of experience, this opportunity is very good for you, and the test is free. So go and apply. So before starting, make sure you like and share this stream. Share this stream as much as possible so that everyone becomes aware that something is taught here. Make sure you subscribe the button. If you click the subscribe button to subscribe to this channel, it will help us motivate a lot. And I will also suggest you that you don't have to like right now. You keep on looking at this video, and if at any place you find this stream like worthy, then only you can drop a like button, or you can click the like button, right? So you can also join this Telegram channel, which is constantly monitored by us. Here you can ask any doubts that you have. So let's finally come to our agenda today. So our agenda today is pointers. So basically we will be bridging the gap among the beginners and already those who know the pointers. So our main focus was on linked list, binary trees and binary search trees, as I've already told in my introduction class. But to know linked list, binary tree and binary search trees, you have to have a strong concept on pointers, right? So how pointers will help you? So one who does CP, one who is very good in competitive programming, basically live out on this concept, the concept of pointers. What happens is that then in the interview you will be asked questions on pointers and you will find it quite difficult to solve. It has also happened to me, it may also happen to you. So to bridge the gap, I will be teaching you linked list, binary trees and binary search trees. But before jumping into that topics, I want to first clear the concept of pointers so that guys from first years also can understand when we go to linked list directly, because everything is based on pointers there. So we will be first starting with a basic class of pointers and then we'll slowly move ahead with linked list, binary trees and binary search trees. My goal is that after this 1 month, you all will be very good in these three concepts and you will be able to answer any questions asked in any companies, right? So let's move ahead. So what we'll be learning, our main focus in this stream will be introduction to pointers. We will be learning everything about pointers initially, and then we'll be learning about pointer arithmetic. After that we'll be learning call by value and call by reference. So this is a very important topic, call by value and call by reference. And after that we will be doing double pointers and multiple pointers, and then arrays and linked list. I hope to cover till call by value and call by reference in this stream, and after in the next stream I will be taking double pointers, multiple pointers, and we'll set a base for arrays and linked list, right? So without wasting much time, let's move to our sketchpad. So I hope my screen is visible. So basically our first topic is introduction to pointers. So we will be first learning introduction to pointers. Sorry if my handwriting is bad, it's very new to me to use this pen. So we'll be first learning introduction to pointers. So what our main focus will be on? Our main focus will be on variables in the initially. Because why variables? Because before jumping to pointers you have to first understand what variables are, what data types are, what do you mean by memory, what do you mean by address, and so on. So let's first jump to our variables. So first we will be learning about variables. So what is a variable? If you think what is a variable by the word you can understand that one which can store different kind of values, right? Variables will be able to store different kinds of values, like its value can change. It's not a constant value. So suppose we have something which can store a value and that value can change continuously. So the thing which can store the value will be calling it variable, and the value which will be changing, it will be called values. So suppose we have some x type, and what happens is that this x can store any value. So what we'll be doing is that this x can store any value. So this x will be called variable and this value will be called value, right? So this value can be anything, it can be number, it can be string, or it can be any kind of thing. But this x will be called variable because its value is not fixed. This value is changing continuously. So this is what a variable is called. Now this variable can be of different type. It can be of integer type. It can be of character type. It can be of long, double, and so on, right? So what we have to do is that we have to think first what this all means. What is int, what is character, what is long, what is double? We have to understand this. So to make it clear, let's take some example. So suppose we have 4 houses, right? One house is red, one house is green, one house is yellow, and one house is blue. So why I'm using this? So I have been an ICSE student. So in my school, I used to see 4 houses. So one was red, one was green, one was yellow, and one was blue, right? We had 4 houses. And suppose there are couple of students. There are couple of students here. So they can be of red type, they can be of green type, they can be of blue, and they can be of yellow, right? So these are the types of people, like these are the students who are wearing red t-shirt, who are wearing green t-shirt, some are wearing blue, and some are wearing yellow. And now we have 4 groups. So what do you think, where will this red data go? This red data will go to the red house, this green data will go to the green house, this blue data will go to the blue house, and this yellow data will go to the yellow house, right? So how are we distinguishing this value to different houses? Same way, there are a chunk of values. We have chunk of values which are numbers, which are floating point numbers, which are characters, which are strings, and so on. We can distribute it among different kinds of houses, and these houses we will be calling data types. So data types will be int, which will have, suppose int is red, so int will only have values of integer type. Double will only have values of double type, floating point type. So there are 2 kinds of floating point data types. It is double and float. For integer type data type, we have integer, long, and so on. For character we have character, char. For boolean we have bool, for, and so on, right? So there are different kinds of values, there are multiple kinds of values, and what we are doing is that we are refining it into one particular houses. So one house, so red house, so suppose integer will have all the integer values, character will have all the character values. So this helps us distinguish different kinds of values, right? So I think I am able to make this clear to you. Now let's jump into okay, now let's understand different kinds of data types. So first we have integer data type, then we have char data type, and then we have float data type. So for the timing I will be discussing these 3 only, right? For the timing I will be discussing these 3 only. So what is integer data type? Integer data type stores integer values, okay? They are not floating values. They are not floating values, right? They will not have any point, they will not have any decimal values. Excuse me. In character we have characters, right? And in float we have floating point values. Characters, what do I mean by character? A single character. A single character can be a, it can be a 1, anything, but it will be enclosed in a single quotation. In float we have floating point numbers, which is 1.75, 2.06, and so on. And integer value will be 2, 45, and so on, right? So this is the core concept of data type. So data type holds a particular type of value, and this value can change. So a variable, if I hope so you remember what variable is. A variable can be of particular data type, and it can hold different kinds of values, but that value has to be of the same data type. So if there is a variable of integer data type, it can only store values of integer types. If it is a variable of character data type, it can store only values of character types, right? And if the variable is a float data type, it can store only values of float data type, like floating values only, right? So now why am I saying all this, right? So to make it clear, so suppose we have integer data type. Now let's just focus on integer. We'll focus on one data type only, right? So this integer takes memory of 4 bytes. Now what is 4 bytes? So suppose we are talking about red house. So red house, a red house person can take 4 by 4. Suppose if one person of red house people stand, it will be taking 4 by 4 square feet, right? It will be taking 4 by 4. Like suppose here is 4, here is 4. So if a person is standing here of red house, so he will take 4 by 4 place, right? So we also have similar kind of mechanism in our computer. So in our computer we have memory, which is also called random access memory, right? It is a RAM. So we have different kinds of memory address, and this memory address has some values marked to it. So the initial, suppose we have some number 501, 502, 503, 504, ... right? So this is what our numbering is. So suppose this is 501, this is 502, this is 503, this is 504. So our memory also has some address. Our memory, you can think that this is some memory which has some size. Like in weights we have 1 kg, 2 kg, 3 kg. Here we have bytes, right? And these bytes are also divided into bits. Bits are actually 0 and 1. 1 byte is equal to 8 bits. Okay, 1 byte is equal to 8 bits. And these bits are, so let's not go deep into that. So you can assume that 1 byte is equal to 8 bits, like 1 kg equal to 1000 gram, and gram is the SI unit. So similarly, 1 byte has 8 bits. So bit is the smallest unit of the memory that a computer can have. So this 1 byte is equal to 8 bits. So 1 byte of memory equals to 1 box here, and integer is 4 bytes. Integer is 4 bytes. So what happens? So if we write a variable, suppose we take, if we write a variable int a equal to 4, or let's take 41, int a equal to 41. So this int will take 4 size, in this memory, and 41 will be written like this. Okay, so it will not be written like this. Actually, it will be converted into bits. So it will be changed into a binary format. And then chunks of like 8 bits. So we have 4 bytes. So 8 bits will be written in each byte. But for convenience, let's assume that this whole block is given to this int a, and this int a will store 41 here. Up to now it is clear. So what we have discussed up to now? We have discussed up to now that if we take an integer variable, right? This integer variable has size of 4 bytes. So if we assign one value to this variable of integer data type, it will be stored in this memory, and this memory will have numberings from 501 to ... This number it depends. Actually, it is a hexadecimal number, but for convenience, let's assume that it is 501. So 501, it goes to 502, 3, 4 bytes. It will store 4 bytes of memory. So this value will be stored in 4 bytes of memory, right? So this is done. So now comes the concept of, now we'll be thinking about the concept of address. So what address is, right? So let's understand what address is. Okay, now we'll be learning about address. So up to now it is clear. So why do you think I have written 501? Why? There should be a question. Why 501? Why I have written 501? So 501 was arbitrary. It can be any number. It will be a hexadecimal number. But why to number it? So if you want to know the exact location of the A, if you want to know exact location of the number, so if you want to know my address, if anyone wants to know my address, what they will ask? Where do you live? They will ask me, where do you live? I will say my address is this. Kolkata, this, right? XYZ. I don't live in Kolkata though, but let's suppose Kolkata, West Bengal, ... So I'll tell my address, and a person can locate me particularly. So if you want some gift to be sent to your friend, right? So you have to give the complete address. You have to tell that this is the address where my parcel should go. So suppose you are sending a letter to someone, okay, and you write everything in the letter, and then in the beginning you write your address, and in the end you write in the beginning you write the receiver's address, and in the end you write the sender's address, right? I forgot the format a little bit. So whatever it is, so we need address to locate a particular person, right? So similarly, how will you locate INTA? You tell me, how will you locate INTA? So we need a particular address. So this is the address that we need to locate A. So how do we find the address? So there is a command. So there is a symbol, and if you use ampersandile A, this will give you the address. And this address will be 501. So ampersandile A will give you the complete address where it is stored. So it will give you 501, right? I think it is clear. So suppose you need to find where this A is stored. Where in my memory A is stored? You use this variable and ampersand of A. Ampersand of A, clear? So if you use ampersand of A, you will find what is your address, right? You will find what is your address. So your address is 501. Now, how will you define how much space it is using? We only know 501, but we knew that the variable is stored from 501 to 504. This was known. So what should come in your mind was that we have already defined INT. We have already defined INT. We know the data type. We know the data type. This is known. So we know the starting address. We know the starting address. We know the data type. So what will be the final address? It will be 504. 501 plus 4 minus 1. Why were you doing minus 1? Because 1 is also considered. This address is also considered. So 501 plus 4 minus 1 is 504. So this is your last address. So this is your last address. Am I making it clear? Let me make you understand one more thing. So what I was saying is that you have 501. Clear? You already have 501. You already have 501, and you know that your INT size is 4. So what will be your final address? So final address will be 501 plus 4 minus 1 equal to 504. Why are we doing minus 1? Because we know the total size is 4 and first address is already 501. So if we do only 501 plus 4, it is giving me 505, which is wrong. This is not my final address. My final address is 501 plus 4 minus 1. So this is my final address. So now we only need to keep track of the data type. Okay, we only need to keep track of data type and starting address. Right? We only need to keep track of the data type and starting address, and that will be more than enough. And that will be more than enough. So this will help us to understand what we are doing in INT, right? So we have covered INT. So we will quickly go through character. So in character we only use 1 byte. So character has only 1 byte, and float has 4 bytes. Double has 8 bytes. Okay, so character has 1 byte, float has 4 bytes, and double has 8 bytes. So I think I am able to make you clear. So similarly, what will happen in character? In character we have 1 byte, so we have 8 bits. So if you are representing one character variable, that will take 1 byte of memory in the RAM. Float will take similar 4 bytes of memory. Double will take 8 bytes of memory in the RAM. Cool. And how to get the address? Address is similar type. So if you have character CH, okay, to find you will use ampersand of CH. If you have float F, you will use ampersand of F, right? So this is clear. Now let's move to excuse me. Now let's move to the main concept that we want to understand, pointer. So what is pointer? Big question, most important question. What is pointer? Let's understand. So in terms of bookish knowledge, we should know first. Let's write it. Variables that store address of another variable. So pointer basically is variables that store address of another variable. Simple. This is the bookish knowledge. But to understand the real knowledge, what it is? Simple. Suppose I know address of my friend. I am pointed to my friend. I know the address of my friend. I say, anyone asks me, where do your friend XYZ live? I say, he lives there. He lives there. When I say he lives there, I am pointing to his address. I am storing his address. My brain is storing his address and I am telling that he lives there. Right? So pointers are same kind of thing, right? Pointers are variables that store address of another variable. So pointer will store address of another variable. How do we define a pointer? We define a pointer by using star. So we define a pointer by using star. So star is the, the variable or the symbol we use to define a pointer. So if you are defining a pointer p, it will be written as star p. So when you write star p, that particular variable will become a pointer type. So this is a pointer type of variable. So what is variable? Variable which can store different kind of values. And what can store different kind of values, which I have already discussed. So variables are something which can store different kind of values. So this is pointer type of variable. So it can store different kind of addresses. Right? So it can easily store address of another variable. But there is one trick. Let me clear the screen and show you. The trick is that if you are using int type of data type, so if a value is int type, int star p will point to int type of data. Char star p will point to char type of data. Similarly, float star f will point to float type of data. Right? Up to this it is clear. So what did we learn up to now? Let's revise. So what we have learned up to now? We have learned about what is a variable. We have learned about what is a data type. We have also learned about what makes a variable. So what makes a variable means it can store different kinds of value, but that value should be equal to the data type that you are using, right? After that, what we have to do? After that, our main focus should be what is a address, how a variable is stored in the memory. That we have seen. Integer has 4 bytes, character has 1 byte, float has 4 bytes, and so on. A byte is 8 bit. So these numbers are converted into binary. Each bit is stored in, like, each chunk of 8 bits is stored there in our memory, right? So this is how our variables are stored in the memory RAM. And after that what happens is that how to understand where particularly this variable is stored. This can be known by doing ampersandile. This ampersandile symbol will help you know the address, and this star pointer will help you point to that particular value, right? It will help you point to that particular value. So till now I think it is clear. To make it more clear, let's do some coding, right? Let's do some coding. So let's start. So let's first see different kinds of variables. So basically I am coding in C++. You can also code in C, Java, whatever you want. Okay, I did some mistake. Just a second. Float f and character ch, right? So this is declaration of variables, right? We are declaring it. So we have declared int a, we have declared float f, we have declared character ch. So we have declared 3 variables. One variable is of int type, one variable is of float type, and one variable is of character type, right? Now we will do some initialization. Initialization means we are assigning some value to the variable. Okay, we have assigned 10 to a. We have assigned float will be point, so 10.67 to float, and character will be a character type. So we have assigned character is a single character, right? So we have assigned a to character. Now let's print out. Now let's print out. So basically in C++, if anyone is finding it difficult, so cout is basically used to display your output. Simple as that. Okay, cout is basically used to display your output, and we have taken so basically this is a basic class. If anyone is finding it too boring, bear with me. We will start it in a few seconds, right? Something important you will learn, something new you will obviously learn, right? So let's bear with me. So this is basically for those who have zero idea about C++, or those who have zero idea about what variables or something are. I want to teach everyone from base to advanced. So anyone who is even very basic or very on the very base level, he can also understand what I will be teaching next, right? So let's learn from base. If you know, it's very good. It's you are getting it revised, but let's see, right? So I have printed. So basically you can see. Let's see, it's loading. Yeah, so basically what output should we get? We should get an integer output, we should get a float output, and we should get a character output. So this is our integer output, this is our float output, and this is our character output, right? This is done. So this was a basic example. Now let's move fast forward to pointers and address. So now let's understand about pointers and addresses, right? So basically what we are doing is that let's first initialize it. So we have declared the variable, we are initializing the variable to 25, right? We have initialized the variable to 25. Now what is our main task? Our main task now is to understand where this particular value is located. So to understand where it is located, we have to how are we finding address? We have already learned we are finding it by ampersand of a, right? So let's find it out. So I have written int. So let's find it out, right? Let's do it directly, not to use. So address of a. Address of a. So how are we getting it? We are getting it by ampersand of a. So this is our first thing that you are seeing, right? Now let's print it out. Now let's print it out. So what basically we are doing here is that we are trying to find the address of a. So here you can see that we got a hexadecimal number. So there we were assuming that it is a 501. I told you already that is an arbitrary number for better understanding, but actually there is a hexadecimal number which represents where your a is present, where in the memory, in my computer, in my machine, where this a is located. This is the exact address where a is located, right? And how do we find the value? How do we find the value? So basically now only we saw how do we find the value. What happened? Control Z. Yeah. So let's do it out. Cout value of a is a. So this will be very basic thing. You already know. So value of a will be a. So first it will give me address, and after that it will give me the, first I have asked for the address and then I have asked for the value. So we got the address as that particular address and value as 25. So I have not given the space, I have gave it the space. You will find it in the next time when I run this code. So next comes our pointer. So let's look in the pointer. So int star p a. So our so it is an integer type of pointer. So for convenience we are using star pi. So pi is pointed to integer type. So this how we are assigning it. We are assigning it by doing ampersand of a. So this pointer variable, when we give it is, this pointer variable stores the address of another variable. That was our definition, if you remember. A pointer variable stores address of another variable. So what is the address of another variable? Address of another variable is ampersand of a, and star pi is pointed to the integer. So this is storing ampersand of a. So basically it is storing address of a. So let's check whether we are doing it correctly or not. So what we will again print out? We will print out cout address of a, right? And this time we will write pa. So this pa not pi actually, pi. So this pi stores address of a, and what will be the value stored in that address? So I know where the address is because I know the address of my friend. Similarly pi know address of a. Now if I know the address, I also know the people, I also know who lives inside. So pi also knows who lives inside, like what is the value of a. So how to find that? To find that we can use cout value of a, and it will be equal to star pi, right? Let's do it. Okay, I can only make a submission in 5 seconds. I think I should use offline something. Let's say I will try to use it in next class. I find online convenient because we don't have to do any setup and all. So what you can see here, first it was address of a by using ampersandile a, and value was using directly a. But now if you can see that we are getting the address of a by using pointed to integer variable pi. So we got the address by printing out pi, and we got the value by doing star pi. Star pi gives us the value and pi itself gives us the address, right? Up to this much it is clear. Let's move. So let's learn some new concept. What is the new concept? Now what do you think we can do? So what do you think if I change the value of a to 10? What all changes do you think we can see here? Let's do some cout like this something. So we have a demarcation kind of, and let's run it. Okay. So what do you think will change? Will the address change? Will the value change? Will pi change? Will star pi change? What all we can change? You can comment it now. I am giving you 5 seconds to comment. So I'm waiting for 5 seconds and then I'll show you the answer. Okay, let's see what our output is. So here you can see the address is not changed. But as expected, the value is changed. But to our surprise, the value of star pi is also changed. So what happened is that if you change the value, now it is a proof Now it is a proof that it is actually pointing to A. Now it is a proof that it is actually pointing to A. Why so? Because when the value of A is changed, Pi was pointing to A, so star Pi should also show me the current value at A. So here you see that star Pi is showing me the current value of A, right? So here it is proved that Pi is pointing to A. We did not make any change to Pi. Did we make a change to Pi? No. We just make a change to A. But what happened was, in turn we can see that star Pi is also changed. So it is a proof that star Pi is pointing to A. Done. And when we change value of A, the value of star Pi is also changed. Now let's do some other thing. Let's copy it. Now we are doing star Pi equal to 44, right? Now can you guess what will be the answer? What all address, whether address will change, whether value will change, whether only star Pi will change and A will remain the same, or both will change? What do you think? Let's run it and wait for 5 seconds for your answer in the comments. Let's see who gives me the correct answer. So it's running, and I think your time is also up. So let's see what is the answer. So as you can see, this is the initial address. And if you come down, you see the address does not change, but to your surprise, the value of A also changes. We have only made the change to star Pi. But value of A also changes. So what is the magic here? So this magic is called dereferencing. So in bookish knowledge, this magic is called dereferencing. Basically what happens here is that when this is basically an example of how to explain. I'm not getting a real life example now, but let's understand in computer terms only. So my star Pi has become a completely duplicate of A, where if you change value of Pi, actually it is not changing value of Pi, it is pointing to A, and there the value is changing. So a pointer variable stores the address of A, and that if we change the value here, actually we are telling, so when I am changing star Pi, actually I am telling that whosoever this pointer was pointing, change that value. So if this pointer was pointing to some other value or other variable, that value will be changed. So this pointer points to whichever variable. If I say change star Pi, this pointer is pointing to that value, that variable, the value of that variable will change. Easy. So in layman's term, if I say change the person living in house A, so that person will change. That much power I have. So this is dereferencing, right? So what you have learned, if you change value of A, it makes sense because star Pi is pointing to A, star Pi will also change. But if you make change to star Pi, A will also change. So basically you can make changes in both cases. You can make change in star Pi, you can make change in A. Both will be reflected in A as well as star Pi. Done. So it is a win-win situation. If you make change in star Pi, A will be changed. If you make change in A, Pi, star Pi, both will be changed. Done. But make sure that address never changes. Now we will be asking that where is Pi stored? This question should come to your mind. Where is Pi stored? So let's see where Pi is stored. So how to find address? How to find the address of Pi? So to find that, we all know. Address of PI /n, and we have AND of PI. Simple as that. So let's comment it out. This much is done. Let's comment it out. So address of PI will be given by AND of PI, right? So let's make some quick changes. Yep. So basically, where address of PI is stored somewhere else, right? PI is stored somewhere else. So it also is of int type, so it takes 4 bytes. It is also of int type, so it takes 4 bytes, and it stores the address. So here, whatever the address of A was, that is stored here. And it is pointing to A, right? So let's see whether the address is same or not. Okay, we got some compilation error. Okay. Let's see. It's taking some time to, yeah. So as you can see, F4, and see, this is not same. Up to now it can look same, but this is not same. Actually it is F8. So it is taking 4 bytes, as you can see. Actually you should not think that memory is given like progressively. It is not true. But in this case it got a progressive value. So you can see after 4 bytes it has 8 here. So 4 to 7 it was stored there, and from 8 PI is stored. But it is not always true, right? So you can see that PI is stored somewhere different, and it is pointing to A. And how we know it is pointing to A? Address of the second address of A, actually it is PA. We have printed PI here, and we have printed *PI here, and this is the address of PI. Correct? Up to this it is clear. Now let's see what happens if we introduce some another variable here, right? If we introduce some another variable here, let's do some comment here and uncomment this value. Uncomment this value, and let's take some int b equal to 25. We are taking so much, right? 51, right? So int b equal to 51, and then let's assign it to b. What do you think will change in this case? Let's run it. Is it running? I think no. Yeah. Let's run it. So what we have done is that we have introduced a new variable b, and we have assigned b to *PI. What do you think will be the value in the next 4 prints, right? Let's see. Okay, I give you some time to think. I give you 5 seconds to think. You think. Okay, your time's up. Let's jump. So as you can see, I think all of you have guessed right only, and if you have guessed right, then my teaching is going in a right way. So what happens is that the address of A and the address that the pointer is pointing does not change. It does not change. And also 51, the value of A changes when we change the value of *P1. So basically it is the replica of the previous example. So what happens is that if we make a change to *PA, only the value is changed. Okay. What address A had, it is same. What address PA is pointing to, it is same as address of A. Even we have assigned B to *PA, we have actually assigned value of B to star PA. This is what I wanted you to explain. So you can also assign direct value, or you can assign a variable to it. It will only pick up value stored in that variable and make changes correspondingly. So since you have made changes to star PA, the value at A also changes. Clear? Let's now see another example, and it will be a bit tricky now, and let's see if you can handle it. End of B. Now let me run it. Now tell me what will be the answer. Will the address be same? Will the value be same? What do you think will be the answer? I give you 2 seconds to think. If you can, you comment, you put your answer in the comment, I will go through them. So what do you think will be the answer now? Let's see. So if you have guessed they will be same, what happened? Why did you get a compilation error? Just a second, let me go through. Okay. So actually star PI was already defined as a, like PI was already defined as a star pointer, like with a star variable. So I have redeclared it. I have written star of star PI it became. So ignore that. So basically what we have done, we have stored the address of B now to PY. So we have now put address of B into PI. So what happened was, the pointer that was pointing to A now points to B. So on changing the value of, so we have actually changed. So what we have done here, we have actually changed the address that was stored in PI. So what happened? Now this pointer is not pointing anymore to A. Now it is pointing to B. So you can see that we have written address of A here, but actually it is pointing to address of B, and instead of being a value of A, it is actually value of B, right? Clear? So it is actually value of B, and this is actually not address of A, it is actually address of B, because this is the actual address of A. This thing here is the actual address of A. And what happens is that now you can understand to change the value of pointer, you have to actually point it to a different variable. So if you write star PA or star PI equal to B, it will change the value. It will only change the value of A, and it will only change the value of star PI. But if you write PI equal to AND of B, why you are writing PI? Because we have already defined it as star pointer. Like we have already used star on PI, so it is already defined as a pointer variable. So if we write PI equal to AND of B, so now it is pointing to B, and now it is pointing to the value of B, right? So I hope it is clear. So without wasting much time on this, I think I have been able to make it clear. Now let's go to next topic. So basically we have covered a little bit of introduction to pointers. I hope you have now a clear concept. Of, let's start from beginning what we have done. So we have done what is a variable, what is a value, what is a data type, different kinds of data type. We have done different kinds of data type, and after that what we have done? After that we have done some what is a memory address? We have done what is a pointer, right? How a pointer points to an address, right? if we know the starting address and we know the data type, how we can tell the range where the data is stored, right? After that, we have seen multiple examples of different kinds of pointers like int pointers, float pointers, character pointers, and so on. We have seen examples of like different kind of like we have seen different examples, like if we change value, how it is affecting star pointer. If we change star pointer, how it is affecting value. How to store address, right? How to store address, how to print address in different ways. We can print address by AND of A, we can print address by only PA, right? We can print value by A, we can print value by star PA. So I hope all this makes sense. So your homework will be go and practice multiple examples like this. And it will be clear to you. Now, since my pad has opened, let's write it. So our introduction to pointers is done. Introduction to pointers is done. If you have any doubts in introduction to pointers, leave your comment in the comment section. I will go through the comments and I will reply to every comment, right? Now let's move to the second topic that we had. Our second topic was pointer arithmetic. So let me write it down. My second was pointer arithmetic. So pointer arithmetic is a very simple concept. It will not take much of the time. So what happens is that you know that when you add 1 to a value, right? 5 plus 1 is 6. 5 plus 1 is 6. 5 minus 1 is 4. 5 minus 1 is 4. So this you are doing on value. We can also do this on pointers. So pointer arithmetic is what all arithmetic operation we can do on pointer. That is pointer arithmetic. So we can only do plus or minus. Minus in pointer arithmetic, right? So what should we think now? So as we have seen, pointer stores address. What do you think? So suppose we have star P1 equal to ampersand of A. What do you think? Why star not written? So what do you think P1 plus 1 points to? What do you think P1 minus 1 points to? What do you think P1 plus 1 points to? What do you think P1 minus 1 points to, right? So this is our question. This is our arithmetic. So we cannot do any multiplication division on pointers. We can only do plus or minus on pointers. So to think about this, so we have plus 1. What plus 1 says? In value what you have done? 5 plus 1 you have set 6. So here also it makes sense. P1 plus 1. It should be some address. P1 is pointing to some address. So you have to understand it. Let me clear the frame and make you understand. It is a good concept, easy concept, but good concept. Let me make you understand. Clear the frame, bro. Okay, the frame is cleared. So what we have is, we have P1. This P1 is pointing to some address which is 501. What you have thought, right? A. P1. Now what P1 plus 1 will do? P1 plus 1 will be a new pointer. Suppose I name it as P2. Don't add it, right? Now let me not write it as P2. Let me write it as P. I understand. Like you will think that P1 plus 1 is P1, P2, P2 plus 1 is P3, like this. So let's erase it and basically write. So let's erase it nicely and okay. So we have PA. So if we add PA, we will be having a new pointer which is PA plus 1. And where do you think it is pointing? Where do you think it is pointing? So now it will depend on the data type that I was focusing initially. So if it is of int data type, PA plus 1 will be pointing to 501 plus 4, which will be 505. So it will be pointing to 505. Why? Because 501 plus 4 minus 1. So this variable is from 501 to 504. So this variable is from 501 to 504, and plus 4 will give me 505. So PA plus 1 is pointing to 505. Similarly, PA minus 1 is pointing to 496. PA minus 1 is pointing to 496. So I think it is making it clear. So actually it depends on the data type that you are using. So if you are using a data type of int, so int star pointer type is pointing to int kind of data, and it is some address. Now PA star is pointing to the value which is stored in the address. PA plus 1 is pointing to next address after this block is finished. So this block is of size 4. So then PA plus 1 will point to after size 4, which is 505, and PA minus 1 will point to 4 blocks above, 4 bytes above. Why? Because it is of int type, 4 bytes above. So it will be 496. Clear? So let's look at an example. I will throw random question to you and you have to tell me. Clear frame, bro. Let's wait for the frame to be get cleared. Okay, so we had int data, right? So suppose it is 501. You have to tell me what P1 plus 3 will be. If it is character type, we have 501. You have to tell me what will be PAN plus 3. If it is double and it is 501 and it is P1, you have to tell me what will be P1 plus 3 in this case. So we have 3 cases. I give you 5 minutes, I give you 10 seconds to think. If you want, you can write the answer in the comments, and if you don't want to write in the answer in the comments, no issue, you write it in your copy or somewhere else, or you can think it on your mind. So I give you 10 seconds to think on it. I have given you int 501 as the initial address. P1 is pointing to initial address 501. What will be P1 plus 3? Initially P1 is pointing to 501. What will be P1 plus 3? And in double it is pointing to 501. What will be P1 plus 3? Right? I think your 10 second is up. So let us think. So one int is equal to 4 bytes, right? So we are jumping by 3 places. So it will be jumping by 12 places. So 501 plus 12, it will be 513. In character, one place is equal to 1 byte. So 4 into 1 equal to 4. So in character, P1 plus 3 will be 505. In double, 1 is equal to 8. So 8 into 3 will be 24. So 501 plus 24, it will be 525. So if anyone has thought this only, then well done. You are understanding my class. And if someone has problem, you can drop in the comments what problem you had, and we can discuss it in the next class, right? So this is clear. I think this is clear. Let's look into a code fatafat. So it will be basically in hexadecimal, so maybe we'll have some issue to understand, but let's see. You can do some homework at home and convert it into hexadecimal and all. My work is to show you, so let me show you. So first we need a pointer. I'm writing it as PA now. Star PA equal to ampersand of A. So this is the address. Now let's write cout current address of A. Current address of A is current address of, let's do it as PA. PA is not PA actually, current address of star PA is. So where star PA is pointing, that is my main name, right? Like where this pointer is pointing to? What address is this pointer storing? So it is storing PA, right? So it is storing PA. It is storing PA. Now what address? What address PA, current address of PA plus 1. So what you have to do, you have to just write PA plus 1. Let's check it out whether we have done it correctly or not. Oh, it will be a compilation error. Sorry guys. Yep, let's check it out. So you can do a homework at home. You have to check like this plus 4 bytes whether it is equal to this or not. So it is actually not making any sense to write like this, but you can assume that PA plus 1 is the only possible thing that we can do. So we can do PA plus 1. PA plus 1 is basically giving you, if you see this plus this minus this will be a difference of 4 bytes only because it is of integer type. And if we do PA minus 1, so let's copy it out. So let's copy it out. Control C, Control V. Arey yaar, just a second. Control C and Control V, and now we are seeing PA minus 1. We are seeing PA minus 1. So you can see that this is some plus for so this is the current address of PA, and this is more and this is less. So this minus 4 bytes will be equal to this, and this plus 4 bytes will be equal to this address. So basically my core concept, the main motive of writing this was you can understand that only plus and minus is allowed. So if we do some division or multiplication, it will give me a syntax error. So I'm not going through it. You can try it in your home. If you use division or multiplication here, you will find that it will give you a syntax error. You can't use multiplication division here. So by multiplying, you cannot go in multiple terms. So basically why we are doing this? We are doing this because if we know, listen to my word, it will be very nice. So if we know that elements are stored in contiguous blocks, and if we know the beginning address, we can easily find out what will be in the last place or what will be in the third place. Let me show you with an example. Suppose, clear frame bro. Okay, let me till it's clear, let me tell you. So suppose, let it be green. Suppose you know that the address, that the values are stored in contiguous memory. So it is stored in 501, it is stored in 505, it is stored in 509 and so on. If you know it is already stored in contiguous memory and you know the initial address P1, so you can easily tell me the address of P1 plus 2, you can easily tell me the value of P1 plus 2. So this is the basic concept of array. Which will become later. So array is basically having elements in contiguous memory, contiguous blocks of memory. So all that is stored here is P1, and P1 plus 1 will point to 4 bytes next, which is 11. and whose address is 505, whose value is 11. P1 plus 2 will give you address as 509 and value as 14. So I hope this is clear. Also, if you know the address of last value, you can find P1 minus 2, you can find P1 minus 1. So basically this sets a base concept of array. So we'll come it laterwards. I think I have already overshooten this 1 hour mark. So we'll be taking the next topic, which was, I think, call by value and call by reference in next part. It is a good topic. It will take some time. So yeah, let's meet in the next class. And before wrapping up, let's first quickly discuss what we have learned in the end. So we have learned about pointer arithmetic. What happens in pointer arithmetic is that we can only, as we can do addition, multiplication, division in integer values and double values, in pointers we can only do plus and minus. What happens is that when you do a plus, it depends on the data type that you are using. So if you are using an integer data type, you are just pointing to the next address by doing plus, and you are pointing to the previous address by doing minus. So if someone gives you a particular pointer to some address, right? So if you know a particular address and a pointer, and you know the pointer to it, you can easily find what will be the value in the next contiguous block, or you can easily find what is the value in the previous contiguous block, right? So both is easy. And also it depends on the data type. So if you have a character data type, it will jump to one place. If it is a double data type, it will jump to 8 place. So this is all, I think. By saying this, I am wrapping it up. Let's meet in the next class. And if you have enjoyed my stream, make sure to like the stream and subscribe to this channel. It will help me motivate a lot. Please share this with all your friends if you like my teaching. And if you have any suggestions, like in my way of speaking or in my way of teaching, feel free to write it down in the comments. Since it is my first class, it will be helpful if I get some positive or negative feedbacks, anything. But give your true feedbacks to me, right? By saying this, I am ending my stream. Let's meet in the next class. Bye bye.